Hello everyone. In this video I am going to show you how to configure Eigrp routing protocol for a network of some company. For this purpose I have prepared some network scheme which you can see on the screen. It consists of 3 virtual offices of some company with virtual devices inside them. One of them being the headquarters office, one is remote large branch office, and the one is small branch office. Basically, internal devices have already been fully pre-configured for this video, and what is left is to configure the Eigrp routing protocol on these customer edge routers that connect to the internet. Let's get started with configuration of internal devices. First, let's start with switch 11. Let's first check local IP addresses on active interfaces. For this purpose, Cisco IOS has the following command: show IP interface brief. So as you can see, a few interfaces have IP addresses. This is basically a layer 3 switch that performs Ethernet switching as well as IP routing. Let's check show CDP neighbors command to see which neighbors does this device see. And okay, there are plenty of devices that you can see on this network scheme for which switch 11 is an intermediate neighbor. Let's check show IP route to see a routing table of the device. Here you can see some lines that start with capital D letter. The capital D letter denotes the Eigrp source of routing information. That is, as I said earlier, I have fully pre-configured internal devices, and this switch 11, does have Eigrp configuration. By the way, why D, you would ask? Well, capital D stands for dual, the algorithm that is used at the core of Eigrp routing protocol, diffusing update algorithm, or dual. I am not going to dive deep into this algorithm. You may find it in the internet or in Cisco authorized trainings. I recommend you Cisco authorized trainings so that will you will have an opportunity to structurize your knowledge and skills about network technologies. So basically, yeah, the routes are only internal because, for example, if you check the addressing inside other 2 offices, for example, 10.1.1.1 network, 10.1.1.0/24, that is. There is no such network in the IP routing table on switch 11. Let's check it specifically. Show IP route 10.1.1.0, and let's use mask. And let's also use the keyword longer prefixes. As you can see, no information about this network, as well as no gateway set, which means that we can't ping this network from inside the headquarters office. Let's try just do this. 10.1.1.1. As you can see, we have timeouts for each ICMP echo request. Let's check where the route stops. And it stops right on this device. Why? Well, because one moment. Because the device does not know either specific route to this prefix or default route. Because R1 and R2 do not execute Eigrp routing protocol. Let's check this. Let's connect to switch 13 and check show IP Eigrp neighbors. As you can see, switch 13 also does have Eigrp configuration, but among its neighbors there is no IP address that belongs to router R1. Router R1 on interface Ethernet 0/1 has IP address 192.168.0.0/31. /31 is quite legitimate mask, but it must be used only on point-to-point links. Okay, so as you can see, there is no address 192.168.0.0 among the Eigrp neighbors of switch 13. So our task is to configure Eigrp on all the customer edge routers. And then we will compare the routing tables from inside each office. So let's just use show IP route command for the historical purposes. Not so much routes. Okay, and let's go to router R1. So router R1 is already been pre-configured, but partially. It does not have Eigrp routing protocol configured, so we can check this by using the show IP protocols command. As you can see, no Eigrp routing protocol mentioned in the output of this command. But we can see the NHRP routing protocol. This is because I'm using DMVPN as a transport, as an overlay transport that connects offices over the intermediate IP internet backbone. So let's check the output of show IP interface brief. As you can see, you may shorten your keywords up to the string that is unambiguously recognized by Cisco iOS parser. So basically what we see here, several physical Ethernet interfaces have been pre-configured with IP addresses. They must be added to the Eigrp routing protocol, except this one. This one is the external interface that connects the office to the internet service provider. So we are not going to include this IP interface, this Ethernet interface, into the Eigrp routing protocol. Also, we have loopback interface. This one we must advertise in Eigrp routing protocol. And also we have tunnel 0 interface, which is pre-configured and which holds the configuration for DMVPN as well as CryptoMap for IPsec encryption. Let's check the configuration of interface tunnel 0. Show run interface tunnel 0. So what we do see here, the tunnel interface has IP address. This IP address is used by a DMVPN cloud. By the way, if we compare router R1 to the configuration of router R2 in the sense of tunnel interface, you can see that this tunnel interface has IP address from different IP subnet 192.168.255.0. This is the mask of 24 bits. Let's compare 192.168.254/24. Okay, also a few rudimentary commands are here, but they do not work actually, because I'm going to use Eigrp in named mode. So I will show you a small trick regarding these configurations and why do we need to disable split horizon and disable next hop self feature of Eigrp. Also, you can see here the configuration of next hop resolution protocol that is required for DMVPN configuration. We see a password. Well, this is just a simple password. In real life, you must actually use more strict and difficult password. We also see the configuration of NHRP network ID, which allows us to differentiate between DMVPN clouds. So basically, this scenario uses DMVPN with two clouds, two IP subnets for two DMVPN cloud. This is called double DMVPN architecture, double cloud or double DMVPN cloud architecture. If you compare this configuration for R2, you see here the IP NHRP network command contains different value 10,001 compared to R1, which holds the value 10,000. So basically R1 and R2 are two NHRP servers or just NHS, next hop servers for DMVPN clouds. The other routers R3, R4 and R5 will establish a connection to R1 and R2 respectively and simultaneously to both of these headquarter routers and will register with an NHS server on each of the routers R1 and R2. So basically let's check show IP NHS, show NHS, yeah, show IP, let's use NHRP. Okay, this is a good feature of Cisco iOS which allows you to get instant help by pressing question mark. So show IP NHRP or show IP next hop resolution protocol reveals this information. We have three routers with these IP addresses on their tunnel interfaces. Take for example this one, 192.168.254.5/32 is actually the IP address of tunnel 0 on router R5. Despite /32 mask, the real configuration is /24, as you can see here, and we can check and confirm that show IP interface brief. Making mistakes is no harm. It's okay, especially in show commands, of course. So as you can see, tunnel 0 has this IP address, but let's check for IP subnet mask, show IP route, and let's use keyword connected. Okay, where is tunnel 0 interface? It's here. Okay, this is the prefix of tunnel 0 interface. As you can see, it has the mask of /24. By the way, let's check the same output on the remote office. Show IP NHRP. As you can see, this router R5 has registered to two next hop servers through two its local tunnels, tunnel 0 and tunnel 1. Let's check tunnel configuration on R5. Show run section tunnel. Okay, as you can see, there are two tunnel interfaces configured on R5. One is for R1 and the other one is for R2. And also you can see different network IDs that are used on R1 and R2, as well as additional configuration IP NHRP NHS, which tells to R5 which IP address executes next hop server functionality in the DMVPN cloud. So basically we have two NHS servers. One is this one and the other one is this one. So basically this is R1 IP address and this is R2 IP address. Let's check show IP Eigrp neighbors command. As you can see, there are no Eigrp neighbors because Eigrp routing protocol has not been yet configured on the R5 as well as on all other devices. So let's start configuration of Eigrp with R1 router. We have to go to the global configuration mode, from which we jump to router Eigrp configuration mode. For this purpose, we use command router Eigrp and then let's ask for help. As you can see, we can use either autonomous system number or a name for named Eigrp configuration mode. Let's use name because the autonomous system number uses or makes us to use the old configuration mode, which is not quite flexible if you are going to implement Eigrp for IPv6 network stack as well. So basically, let's do our configuration with command router Eigrp lab. We get into the config-router configuration mode. Let's ask for help, and as you can see, there are not so much commands in this configuration mode, but Cisco IOS does have the extensive tree of commands under router Eigrp lab, and let's just see it. Our next step is to tell Eigrp which autonomous system number it must use. For this purpose, we have address family command. Let's check the continuation of this command. Let's configure IPv4 network stack, routing for IPv4 network stack. And here you can see the autonomous-system option. Let's use this option. So address family IPv4 autonomous system and just the number. The number for autonomous system must be the same among all routers that you are using in your environment. Otherwise, Eigrp routers will not establish Eigrp routing adjacency. So autonomous system number 1. And we get into the address family configuration mode. And as you can see, this configuration mode does have more options to continue to configure Eigrp routing protocol. What we need here, basically one of the requirements of DMVPN solution is to disable the so-called split horizon feature of distance vector routing protocols on headquarter customer edge routers, because these routers must accept routing information from one office and send the same routing information through the same tunnel interface to the other offices. But since this tunnel interface is of type generic multipoint, GRE multipoint, generic routing encapsulation multipoint interface, the split horizon feature of Eigrp will prevent forwarding this routing information from one office through headquarters to the other office or to other offices, in case there are more than two offices here. So basically we need to use AF interface configuration mode, and we must specify the interface for which we are going to disable split horizon feature of Eigrp, because split horizon feature can be disabled only on per interface basis. So we here use tunnel 0 as an interface for disabling split horizon feature. And as you can see, indeed, you have here split horizon option. So basically I can copy this and type no and paste split horizon keyword and just press enter to disable split horizon, so that routing information between remote branch offices would flow through headquarters and would overlaid or switched from one side to the other through the same tunnel interface at R1. And also we must disable next hop self feature. What this feature is for? Well, this feature allows the R1 would allow R1 to set its own IP address here as the next hop for the prefixes inside this office when R1 relays this routing information for the other office, for this one, and vice versa, of course. So why we must, or at least should, disable this feature? Well, when we disable this feature, as you will see later, R1 will preserve the next hop of the remote branch office, when relaying this routing information to other remote offices. That's why we need to disable this next hop feature. Okay, but this is not all. This is not a complete configuration for Eigrp routing protocol, because we must advertise network, right? So we must return to the address family configuration mode, and for IP address family in the config router AF configuration mode, we must specify for which networks we are providing the routing with the Eigrp protocol. The structure of this command is as this. Network, this is a keyword, and then your network that you are going to advertise in this routing protocol. Okay, so which networks do we have? We have 192.168.0.0/31, 192.168.0.2/31, etc. But we can issue just one command, just one, because this is actually a wildcard definition. It must contain all the subnets on locally configured interfaces. So if I issue 192.168.0.0 with default classful mask of /24, in this case I don't need this wildcard mask. I can just press enter, and lo and behold, we see two Eigrp neighbor relationships formed with two neighboring devices, 192.168.0.3 through interface Ethernet 0/2 and 192.168.0.1 through interface Ethernet 0/1. So basically, through these two internal interfaces, router R1 has just established an Eigrp routing adjacency with these two devices. So let's first check its routing table, because those switches, those multi-layer switches, have already announced to R1 all the prefixes that they know. These are internal prefixes inside this headquarters office. So let's issue do show IP route Eigrp command. And indeed, we can see the Eigrp routes for this local office. All these prefixes belong to this headquarters office, and no prefixes are seen from other offices. For example, 192.168.1.1 128/24. This is the subnetwork on VLAN 1 on switch 8, SW8. So let's check for this network. Show IP route 192.168, I'm sorry, .1.128, and let's use mask 255.255.255.128, and let's use longer prefixes keyword. Of course, do show IP route because this is not native mode of configuration for show commands. So I should do show IP route, etc. And as you can see, there is no route specifically to this network. Even default gateway. We have only default gateway. So basically, if we start sending ICMP echo requests to this network or to the first address in this network, we don't get it because we have not yet enabled our Eigrp routing protocol for interface tunnel 0. This interface is obviously from different network of type class C. So let's do it. Okay, network. Let's advertise 192.168. Whichever 254.0. Okay, 254.0, and there are no routing adjacency formed because I have not yet configured Eigrp on all other customer edge devices. Okay, so that is pretty it for router R1. Let's get over this configuration mode and save configuration to the local non-volatile random access memory. And let's move to the R2. To speed up configuration, I will just use show run section and this string R space E that stands for router space Eigrp. Okay, so I see just the excerpt of my running configuration that pertains only to router Eigrp. I just filtered by this string and used section keyword to produce the output for the router Eigrp configuration section. So basically what I need to copy everything and paste it in the R2 console. But first I need to go to the global configuration mode and just pasting. Oops, I would better not leave address family configuration mode. Why? Because I need to edit this network statement because I do not have this subnet locally configured on the interfaces of R2. The subnet is 192.168.255.0. Let's check it. Do show IP interface brief, include, and let's just filter by this string. Oops, include, missed include keyword. And so you can see that we actually have address 192.168.255/2. If we also check do show IP route and just use this filter, we can see that on tunnel interface, tunnel 0 interface on R2, we have 192.168.255.0 subnetwork. So let's configure this subnetwork. Let's first delete this one. To delete a configuration, you just prepend your command with no keyword. And now I can press up arrow, edit this string, press Ctrl A to go to the beginning of the line, and Ctrl D to delete those two symbols for keyword no, and press enter. Okay, so as you can see, when I pasted this configuration, the router found two Eigrp neighbors, which are actually the same internal switches, switch 13 and switch 10, just their other IP addresses. Configured on interface Ethernet 1/1 on both these switches. Okay, so configuration is ready on our headquarters. Let's first write this configuration to NVRAM, and let's check it. Show run. What I forgot. No, actually I haven't forgot anything because I have pasted this configuration. So the no IP split horizon and no next hop self has already configured for interface tunnel 0 inside the router Eigrp lab configuration submode, AF interface configuration submode. So let's go on to show run. Let's check configuration of Eigrp on R2. Okay, so basically configuration is in place. So let's go to R3 and configure the R3 router. The same steps must be performed here. Router Eigrp, you may press tab key to complete the keyword. Okay, and address family, as you remember, this must be IPv4. Autonomous system number 1. Here we issue a couple of network commands. 192.168.1.0. This is the local network that is used in this branch office. I will use just a wildcard network to cover a few local interfaces that have IP addresses belonging to this wildcard network. And yeah, we see two new neighbor relationships that R3 has established with two its neighbors, switch 8 and switch 9. And another network command for 192.168.254.0 network. Okay, as you can see, a new neighbor relationship has been established through tunnel 0 interface. That is the Eigrp routing adjacency with R1 router. And the same for the R2 network, for the other DMVPN cloud. Yep. Okay, so basically that's it. We do not need here to disable split horizon or next hop self Eigrp features on a per interface basis or whatsoever, because this is not a headquarter. Okay, let's check routing table first. Show IP route, and let's use Eigrp keyword to narrow down the output to just the routes that are received through Eigrp routing protocol. As you can see here, we have routes from headquarters office. Nope, it's local. It's local. These are from headquarters. Also, so 10.0.0.0/16. Let's check for 10.0.0.0. Yeah, 10.0.0. Now 10.0.1.0/24 belongs to this large IP block. 10.0/16 means that first two octets must be 10 and 0. So These are basically subnetworks from the headquarters office. And yes, indeed, as you can see, the outgoing interface from the point of view of R3 router is either tunnel 0 or tunnel 1. We have here for each of such prefix 2 equal cost multipaths. So let's go on configuring Eigrp in named configuration mode for R4. Basically, for R4, I can again copy paste the configuration from R3. So let's again use show run command, section, tunnel, nope, section R space E. Okay, let's copy this. Let's open the console for R4. Let's go to global configuration mode and just paste this configuration. And yes, you can see several adjacencies have just been formed from this router with internal devices. I have configured here a VLAN in which R3, R4, switch 8 and switch 9 participate. This is VLAN 10. So we will see do show IP Eigrp neighbors 1, 2 and 3 neighbors in the same subnet, which are R3, switch 8 and switch 9 from the point of view of R4, as well as 2 neighbors of tunnel 0 and tunnel 1 interfaces, which are R1 and R2. And let's check the show IP route command output, and we can see that there are plenty of routes for both internal prefixes of this office as well as for headquarters. But still we don't have routes for small office. For example, let's try to find the route for 192.168.2 and .128/25. This is the subnetwork for this IP address with /25 mask. So show IP route 192.168.2.128 and mask. So basically network is not in table, right? Because this branch office has not yet formed Eigrp adjacencies with headquarters office. So let's go to R5 console and configure it according to our requirements. Router Eigrp lab, and then I must use address family configuration mode for IPv4 network stack, and I must configure autonomous system number, and I get into the config router AF mode. Here I must use network commands in which I will advertise locally configured IP subnets or IP networks. Okay, the first network is 192.168.254. Let's start from this one. 194.168.254.0, and I don't need wildcard mask. And okay, Eigrp routing adjacency through tunnel 0 is up. Let's then bring up routing adjacency through the other tunnel, tunnel 1. So basically R3, R4 and R5 have 2 tunnel interfaces to both of these routers. But router R1 has only 1 tunnel interface, tunnel 0, as well as router R2. In the future, I'm going to add two more tunnel interfaces, one for R1 and one for R2, and I will use cross links to provider edge routers, but this is a topic for another video. Okay, then I must form an adjacency with internal device, which is just SW switch over interface Ethernet 0/0, which has IP address 192.168.2.1. I can do 192.168.2.1. I can use exact IP address of interface as well as just a network, as you can see. And yep, another adjacency has been just formed. So let's check show IP Eigrp neighbors, and we have that R5 now has 3 routing adjacencies, 2 routing adjacencies over the internet with routers R1 and R2, and 1 routing adjacency with internal switch, multi-layer switch SW. So let's check show IP routes, show IP route. So as you can see, this router does have routes both from headquarters as well as for remote large branch office. Now let's get back to remote branch large branch office, and let's check routes on switch 9. And let's check route for subnet inside this small office. For example, 192.168.2.128/25. Okay. So what we can see here, there are 2 routes to this network from this branch office. One is through 192.168.1.2, and the other one is through 192.168.1.1. These are 2 routers that are front-end routers in this office, R3 and R4. Let's then check routing information for example, R4. R4 is here. So basically, switch 9, I can just copy paste this command to speed up the checks. Okay, what we do see here, as you can see, next hop has been preserved. So from the point of view of R4, it sees a route to 2 routes to 192.168.2.128/25 through 2 IP addresses of 2 tunnel interfaces on R5, not on R1, which has IP address 192.168.254.1, or R2, which has IP address 192.168.255.2. So basically, no next hop self is a feature that allows branch offices to see each other's next hops for prefixes inside these offices. Basically, I'm using DMVPN Phase 3 here in this my laboratory. So when there is traffic between offices, these routers may and will establish dynamic IPsec tunnels, and they will be direct IPsec tunnels between, for example, R4 and R5. But they will be able to do this with the help of next hop routing protocol and next hop servers for DMVPN clouds that are configured on these 2 headquarter customer edge routers. This is the end of this video. If you have any questions, please contact me. Bye.